In section 4.4, we'll talk about how you take the derivative of the composition of two functions. So what we're going to do right now is I'm going to just review a little bit about composition stuff with you. In particular, so what does composition mean? So let's say that we have two functions. So we'll just take, say, x squared and g of x is something like x plus 5. Okay, so what did we mean when we said f of g as a function of x? That means to plug g into f. So this is by definition f of g of x. What is f? Or excuse me, what is g? It's x plus 5. And then f of a thing is thing squared, so f of this thing is this thing squared. Okay, so then you could of course compose in the other order. Now what I actually want to look at now is not so much how we do composition, because in a way we've already done that before, but how can you look at a function. So let's say that somebody came along and told us that they had a new function, and I'll just call it h, that was this function here. So can we decompose this back into two simpler pieces that get composed together? Okay, and so what we would say here is, yes, if you let f of x equal, say, x squared, and g of x equal x plus 5, then h is f compose g. So this kind of decomposition is really what we want to look at strongly here. And we're going to use maybe slightly different letters for it than all these x's. And that may seem a little funny at first, but there's a good reason for it. Okay, so what we're going to do is, so let's take a function, a new one. Let's say that we have y equals 4x minus 7 to the 5th, and we want to decompose this. And the way we want to decompose this is in three pieces. So I'm going to make a little table here. Okay. And in the first entry, I'm just going to have my original function. So just copy that down in here. Same thing. And then I'm going to think of an inside function and an outside function. And now what may seem a little funny is I'm going to think of the inside function as being a thing called u. And the outside function is going to be a function of u. Okay, so what's different here than in the last example is that we're in a way introducing a third variable. We had x, or I guess the second variable. We had x before, but we're also going to use this new variable u. So what is f of u here? It is u squared. And what's g of x, which will be u? It'll be 4x minus 7. Okay, now, how do I know that? I want this thing here to be f of g of x, and that's the same thing as f of u, okay, because u is g of x. So I wanted to decompose this into two functions that get composed together, just like over here, to give me the function that I started with. So in a way, this u function is kind of like the insides, and then, oh, and that should be u to the 5th, not u squared, sorry. It was u squared a minute ago. And then what happens to it, this parentheses group, it gets raised to the 5th, so my outside function is going to be u to the 5th. Okay, so Right. Now let's just compute and make sure this makes sense. What is f of u? Well, what is u? F of u is u to the fifth. And we said here that u is 4x minus 7. So I'm just going to substitute that for the u, and then the whole thing is still raised to the fifth. And lo and behold, we get the original function. Okay, so we've just taken this function and broken it into two smaller pieces, the inside in a way, and then what happens sort of overall on the outside. So this decomposition is going to be very important. Now, what we're going to do in class is ask ourselves, well, how do you take the derivative of this? And so there'll be a special rule for that. But that rule depends on doing this sort of decomposition, at least at first. So the pre-class problems are pretty similar to this, should be relatively straightforward. In fact, there's even no calculus. We're just decomposing a function, sort of complicated function, into two pieces that get composed. And then in class, we'll look at how to take the derivative of such a function.